Okay, let's start.
Okay, so hi everyone. In this video, I will briefly walk through what we did to improve the performance of a regression model for the computation, and how we assessed and thought about the model fit. So our overall goal was to minimize our RMIC on the test set while keeping the model generalizable and not severely overfitting the training data. So to improving performance, the first thing we focused on was data processing and feature engineering. So we combined the training and data sets together so that we could apply the same progressing steps consistently. For categorical variables, we used one hot encoding to transform them into numerical features that our models could work with. This allowed us to retain as much information as possible from categorical fields like neighborhood or property type. We also handled missing values by filling them with zeros after processing. While this is a relatively simple strategy, it allows us to avoid losing observations due to missing data and ensure that all models could be trained without errors. So next, we try to improve performance by using multiple models instead of relying on a single regressor. So in our notebook, we tried several different models including lasso regression, elastic net, chargeability boost, and LightGBM. So each of these models capture different patterns in the data. For example, linear models like lasso and elastic net are good at handling high dimensional features and reducing overfitting through regularization, while tree-based models like chargeability boost and LightGBM are strong at modeling nonlinear relationships and interactions between variables. So after training these models, instead of picking only one, we used a simple ensemble strategy by averaging their predictions on the test set. The idea here is that different models make different types of errors, and by averaging them, we can reduce variance and improve overall predictive performance. Finally, we paid attention to model configuration and stability. For example, we set random seeds to make results reproducible, and we adjust some basic parameters to ensure the models could convert properly. While we did not perform very extensive parameter training, combining multiple reasonable strong models already provide a noticeable improvement in leaderboard performance. So overall, our main performance gains came from three things: consistent processing, using multiple model types, and combining them through assembly. So in terms of assessing and improving model fit, we mainly focus on balancing bias and variance. We use regularized linear models like Lasso and LassNet to control model complexity and reduce overfitting. These models shrink coefficients and effectively performance feature selection, which helps to prevent the model from feeding noises in the training data. At the same time, we included more flexible models like ChartBoost and like GBM, which can feed complex nonlinear relationships. The risk with this model is overfitting, especially when the model becomes too complex. By combining simple linear models with more flexible tree-based models, our assemble aims to balance underfitting and overfitting. So another aspect of our fit we considered was feature representation. So one hot encoding increased the dimensionality of the dataset significantly. Linear models benefit from regularization in this setting, while tree-based models can naturally handle sparse features. Using both types of models in parallel helped us avoid relying too heavily on one representation of the data. So although our current notebook does not explicitly plot learning curves. Constantly, we use the idea of learning curves to think about model fit. So if we had more time, we would extend our approach by plotting training and validation RMIC against training set sets to more directly diagnose underfitting versus overfitting. So this would help us decide whether collecting more data, simplifying the model, or adding regularization would be the best next step. So to sum up, we improved our model meant by cleaning the data, trying different types of models, and combining their predictions together. Using both linear models and tree-based models helped us balance underfitting and overfitting. And that's all. Thanks for watching.